its computer so that we can move forward. I'm going to share my screen so we can all be looking at the same picture. Board 1, do you want to talk a little bit about what you've done, what you've put?
So for our board, we had a ball and a Lego car, and I just pushed them together. The ball was moving in a positive direction at first, but then like the car was moving in a negative direction. But then after the collision, they both moved in a negative direction. The car and the ball seemed to slow down like at first from friction, but then like the ball sped up after the collision, and the car was still slowing down more. We know from the data set that the car was faster first, so it's traveling at like faster speed, and then the ball was faster after the collision. So like you can see from the dots that it had bigger displacements from the motion map.
So the red dot is which object?
The red dot is the ball, and the green dot is the car.
Okay, and your claim was that which one was going faster at first?
The car was going faster at first, and then the ball was faster after the collision.
Okay, Thea and Oliver, do you want to talk? How did you know that one was going faster than the other?
We knew that. Oh.
Yeah, you can go.
Oh, okay. We knew that one was going faster than the other when the dots like were more spaced out or close together.
Okay. Yeah. What else? What's another way to know that?
Oh, in the data set, like it shows the velocity, and it was higher for the car than it was for the ball.
Okay. And then what's interesting is that you have set up, I'm going to doodle a little bit on yours, right? Is that a doodle? Or is that's a doodle. So come on, there we are. So what the beauty in your experiment is that you only have one axis, right? It's like this, it's like the X direction kind of thing, right? And so you're either going in a positive direction, means you're going this way, you're going up, or that way you're going down, right? And do we see one that's steeper than the other? Not sure. Do we see one steeper than the other? I think the green is actually steeper. And the green is going down steeper than the red is going up. Do you guys believe that? All of you who are looking at this curve, do you see how if you were to look at the graph of the red here and the graph of the green, am I just making this up, that it feels like the green is going down steeper than the red is going up? Do you guys believe that? Maybe, right? So if it's steeper, it's faster, right? And then after the collision, the red is steeper than the green. So the ball is going faster than the car, right? And the car is going backwards the whole time because you see it's going down, right? And the ball was going forward and then it's going backwards. Cool. That's awesome. Thank you so much. Team 2. That was Natalia, Molly, and Harry, maybe? Yeah.
Okay, so oh god, okay, so I guess we thought that our objects had a constant velocity because I mean they were moving at the same speed, same position, and so yeah, there was a collision right at the graph when they're the two objects are at the same point.
Okay.
And Would anyone else like to talk? Natalia? Yeah.
Yeah, so we didn't have our screenshots, so we kind of just made a really quick sketch of what it kind of looked like.
Mhm.
One was going, or in the graph, it seems like one is going downward and then one is going upward, and then they collide when like both lines meet. Yeah.
Cool. So again, we want to make sure that we're super clear with our vocabulary. What is going down and what's going up? Is it the line or the object?
The object. Well,
Molly,
the
what do you think?
object is moving. Okay.
Is it the object or the line that's going up and down?
The line, but object one is going up, and then, or line one, however you want to, and then line two is going down.
Yeah, it's not however, it's like, it's actually really, really important. So the line one is going up and the line two is going down, right? Or the green line is going down, the blue line is going up. What were the objects doing? The objects was going on the flat surface, right? They're going right or left, but they're neither going up or down, right? The objects were on the flat surface. And you said that there's a collision when the two lines intersect? Yeah?
Yeah, I guess.
And then after the collision, they kept going in their respective direction? So they went through each other? Is that what happened?
Nope. Yep. We messed up on that.
Right, so be careful, right? The object intersected, right? This line went up, this one, so this object went forward, this object went backwards, right? And when they collided right here, where the lines intersect, and then object green probably, so this object went this way, right? So that's backwards. This object went this way, that's forwards, right? And then when they collided, which is right here, then they probably bounce off each other. So this should be, those two lines should be interchanged, right? Cool. 3, what do you got?
So the ball on the left was moving forwards, which means it's the yellow dots, and the ball on the right was the red dots because it's moving backwards. And we thought they both moved at a constant velocity until they had a collision, which then they kind of slowed down.
Okay.
And we thought they were going the same speed because they're kind of parallel before the collision. And there's definitely a collision because they are going towards each other and then they change direction after they've hit each other.
You said that something was parallel. Could you talk to me a little bit about what was parallel?
Their speeds are, I guess you couldn't call it parallel, but before the collision, they have the same speed.
How do you know that?
Because they look the same. They have the same slope.
They have the same slope, right? So, and the slope of which line are we talking about?
We're talking
This line?
both of them because they both have the same speed.
Here, right? Those are the slopes that we're talking about?
Yeah.
So you follow the green dots and they go up and they go forward. You follow the red dots, they go backwards, and they're about equally steep. So they're both going at the same speed, right? Same velocity. And then they collide right here and then they move back, right? And then on the way out, it looks like, actually, it looks like they have kind of like, maybe the green is a little less fast than the red, maybe. Cool. Awesome. Excellent. Thank you. Okay, 4.
Okay. So the red one was speeding up throughout the movie because when the collision happened, the velocity was transferred from the blue to the red. The blue was faster before collision because the displacements were farther apart between each frame. There was a collision because on the graph, the points converged into a single spot and then split apart when they were knocked together. before the collision, the red was going down, and then after the collision, because of the momentum that was transferred, it was going up. And the blue leveled out.
And for people who are kind of confused, on the graph, the yellow, like the yellowy green, that's the red, and the blue is it got mixed
Yeah,
up, and the
but
blue is the
other
red.
colors did
Just
that.
so people understand.
Yeah.
Totally understand. So know that you can change that on your graph for the sake of, like, if you ever wanted to do this exercise again, right? You can, I believe if you double click on the dots, you can actually change their color. So you could make the dots have the same color on the movie and on the position time graph, which would be, again, right, which would be convenient. So again, constant speed here, constant speed. I'm sorry, what's going on there? Can't sync your changes. Really? Disappointing. Okay, whatever. My internet seems like it's being weird. So it looks like the green dots are moving forward or backwards?
Backwards, and then
They're moving backwards. Right, backwards, right? Green dots are moving backwards, red dots are moving forward, and then they collide, and somehow the red dots keep going forward, and now the green dots are going forward as well. Awesome, excellent. And then, excuse me, can you just get, I need my, okay, and then the last one is this one. So, please, what the heck? Can't see changes. Oops. Okay, so Marlo, you want to talk to us about your slide? Yeah.
Sure. So basically, I had a tennis ball and like a spool of ribbon. What I did was I kind of just rolled the tennis ball into the ribbon and then see how it would, or that's not a word, saw how it would react.
Mm-hmm.
Basically, well, I couldn't actually capture like the full set of data points for the table, but in the small part there, you can see it's kind of like the second object is the tennis ball, so it was going really fast at first because I pushed it into the ribbon, but then it just kind of slowed down because it bounced back.
Okay.
Yeah. And then I know that both objects slow down in the end, but the tennis ball was going faster at first.
Awesome. And you know that because?
Because the force of the collision kind of forced the tennis ball to slow down, and then eventually the ribbon ran into a wall, so it stopped.
Got it. Okay. So this was sort of an introduction on the fact that you can track more than one object. You can still have the conversation about whether things are going forward or backwards. You have to be a little bit careful when you do collisions about making sure that you your X and Y coordinate kind of makes sense, like in order for them to, so it's easier if you have things that are colliding in one direction, like so things going right, things going left, and then going, forward and backward like that. If you do a movie like two pool balls that are like hitting each other, it gets more complicated. Okay, I think I want to stop here. So I'm going to stop that. I'm going to stop. Let's see, where am I? I'm going to